Hello everyone, hope you all are doing well. So in this video, we'll discuss the second problem of Leetcode Weekly Contest 353. It's a medium level problem. I've already created a video on this one. In that, we have discussed the iterative approach of how to solve this problem using dynamic programming. But yeah, this video discusses about the recursive approach, right? Because obviously that's easier to understand. And I got a number of requests to create this one as well, right? So the solution is similar. It's just that here we'll be using recursion plus memoization to do this, and that video discusses about the iterative approach. Okay, so let's start discussing it. The problem name is maximum number of jumps to reach the last index. It says that you are given a zero indexed array nums of n integers and an integer target. Okay, you are initially positioned at index 0. In one step you can jump from index I to any index j such that obviously it should be a valid index, right? That means I should be on the left hand side, j should be on the right hand side. You only jump from left to right. Okay, and the absolute difference between those two values should be less than target, right? Here it is written that it should be between minus target to plus target. In short, the absolute difference between the source where you are standing and the destination that to the index where you are jumping, the absolute difference between them should be less than equals to target. Okay, return the maximum number of jumps you can make to reach the last index. If there is no way to reach the last index, return -1. That's it. That's the problem. Okay, let's see this case. It's 1 3 6 4 1 2. Okay, target is 2. That means I have to make jumps such that the absolute difference between my current location and the location to which I'm jumping should be less than equals to 2. So I can make a jump this one, right? I cannot make a jump from here to here because the absolute difference is more than 2. I can make a jump from here to here, however, right? Similarly, I cannot make a jump this, I can make a jump this, right? So total 3 jumps. I have to return the maximum number of jumps, right? So total I can make 3 jumps. Similarly, the second example, 1 3 6 4 1 2, target is 3. Yes, I can make a jump from here to here, then here to here, this one, this one, this one. Total 5 jumps I can make, hence 5 is my answer, right? Remember, I have to return the maximum number of jumps I can make, right? Now let's come here. It's 1 3 6 4 1 2. The target is 0. So from here to here you cannot make a jump, or I would say you cannot make a jump from this location, right, to this location. Getting it? So even if you make a jump from here to here, suppose if you make a jump from here to here, right, this is the first jump you make because the absolute difference between them is 0. But what about this? You cannot make a jump from here to here, right? Because the last value should also be 1. Then only you can make a jump from this location to this location. Hence, -1 is the answer in this case because you cannot make a jump, right? Now, the number of elements that I can have is 1000, and each value is between this, target is this, and so on, right? Now, again, I've already told how to approach this problem in that video, but again, let's do it separately in this video, right? So look, you cannot apply a greedy approach here. Why? Let me tell you this. Suppose your array is like this: 1 4 7 10, then it's 1, then 2, then 3, then 1 2 3, and suppose your target is 3, right? These are the elements of your array. Now what do I mean by greedy approach? By greedy approach I mean that from this location I directly check that can I jump to the next location, and so on, greedily picking up the current location. Okay, so if you do that, let's see what will be the answer in this case, right? You can make a jump from here to here, good, because the absolute difference is 3. Make a jump here from here, make a jump from here to here, great. I made 3 jumps and I've landed on this index, right? But now can I make a jump from this location to any of these indices? No, because the absolute difference here is just see 9 8 and 7, but it should be less than equals to target, right? So it fails, right? It fails. So that's what I'm saying. This is not something you will do in this case, right? You have to check every possibility. You have to check every possibility. What do I mean by every possibility? That means suppose from this location I can jump to this location, this location, this location, this location, or whatever are the locations, right? So what I'll do, suppose let's take an example. Suppose this is one of the indices, right? I know what are the maximum number of jumps I can make from this location to the last index, right? Suppose I know how to calculate it, right? Then all I need to do is that from this location 1, from this particular location, I'll just see what are the indices that where I can jump from this location. What are the indices I can visit? So like for example, I can visit this index, this index, this index, this index, and so on, right? So suppose I can visit from this index to 3. So I already know what's the maximum number of jumps I can do from 3 to the last index. Suppose that is x. Now one extra jump and I can basically jump from the first location to the last location, right? How? One jump is from here to here, and then I already know the answer from 3 to the last index. Getting it? Similarly, if I can do a jump from 1 to 2, let me just change the color for clarity. Suppose I can make a jump from this location to this location as well. I also know the maximum number of jumps I can make from 2 to 3. Then again, what will be my answer in this case? It will be 1 plus the maximum number of jumps I can do from 2 to last index. Okay. All I mean to say is I have to consider all the locations. If I'm looking for first, I have to consider all the locations to which I can go from this particular index, right? Suppose I have to calculate the answer for this location. So whatever are the positions where I can visit from the first location, let's assume this, right? So what I'll do, I'll pick up the maximum between these locations. Let's call the max as max. 1 plus max will be my answer, right? That the maximum number of jumps that I can make from this location is 1 plus the maximum value that I get from all the locations which can be visited from the current index, right? How I calculate it? Consider any other index. Suppose this is 7, right? From this 7, what are the indices I can visit? So here, suppose there is only one index in this case. Let me consider this case, okay? Let me write the array once again. 1, 4, 7, 10, 1, 2, 3, 1, 2, 3. Okay. Suppose I have to calculate the answer for this one, that what's the maximum number of jumps I can make from this index to the last index, right? This is what I'm calculating at every step. So finally I'll be calculating the maximum number of steps from this location to the last location. What will be the answer for this one, right? Just see that to which positions can you visit from here. This. So just find out the maximum number of steps that you can visit from all these locations, and 1 plus that value will be your answer for this location. Simple, right? And obviously you'll be calculating the answer for values on your right hand side, right? Values on the right hand side. This is what we need to do. I'll write a simple recursive code for this one using the same approach, and to avoid recalculating the same answer, I'll just memorize it. Okay, let's start. It will become crystal clear. The problem is very easy. Okay, this is the number of elements I have. This is the DP array I have taken. Why? So that I do not recalculate my answer. Okay, initially all the values are filled with -1. This is to identify that whether the answer for the current index has been calculated or not. What do I mean by answer? DP of I means the maximum number of steps I can take from ith index to n-1th index. So ultimately DP of 0 will be my answer, right? The maximum number of steps I can take from 0th index to n-1th index. That is why initially everything is -1. Okay, answer equals to, just solve, call this function. What are you passing? So this is the index, the current index. So I need to calculate the answer for 0. This is the DP array. This is the nums. This is the target. Okay, let's come here. Index, DP, nums, target. Forget about this base condition. Forget about this as well. What is my core logic? I said that to calculate the value of ith index, I'll visit all the index on my right hand side. So it starts from, if my current index is idx, so it starts from idx plus 1 to n-1. That is what I'm doing. I equals to idx plus 1. It goes to a length I plus plus, right? Now, how do I know that can I visit this particular cell from ith index? Simple. Maths.absolute value of nums of I. Okay. Nums of I minus nums of index is less than equals to target. That means yes, I can visit this index, right? If I can visit it, okay, grab the answer, get the answer for this particular location. Which location? Ith location. How do you do that? Answer equals to math.max of answer 1 plus, because this is one extra jump you have to do. So one extra jump that I do from here to here and the answer for here. So solve for current index being I, okay, DP nums target. Simple. This is your answer, and finally you do it, right? Now let's come to this function again. So just see, what is my base condition? If I reach the last index, right? If I reach the last position, then I do not need to do any jump, right? I've already reached the last distance. So maximum number of jumps that I can do at the last index is obviously 0. Then what is the other thing? DP of index is not equals to -1. That means if I have calculated the answer, initially everything was -1. But if I have calculated the answer for ith index, do not recalculate it, just return it. If you have not calculated, do all this stuff and basically do dp of index equals to answer. Simple stuff, right? Just avoid recalculating it. This is what we are doing. This is the simple approach that we can do. Now, one extra thing to note here. One extra thing. Remember, at every step, my answer equals to min dot value, right? Sorry, min dot value. This is also because, look, there could be conditions that, suppose I go from this to this. That means the absolute difference between these two indices is less than target. Great. Absolutely. That's a great thing. But the maximum number of steps that you can go from here to n minus 1 is not possible. That means from this index, you actually cannot reach the last index, right? Suppose this is 0, just taking an example, right? And the last index is 5. Okay. So what I mean to say is, from here, you cannot reach here. If you suppose your target is, let's assume 0, just taking an example, there is a possibility that from idx you cannot go to n minus 1. So for that, what we are doing, we are returning integer dot min value, and here we are taking max, so that will be encountered. That is the reason, right? I'm not returning minus 1. Minus 1 signifies that value has not been calculated, and min value signifies that yes, what happens in this case, that you cannot reach from the current index to the last index. That's the only extra thing, right? You can take any other value as well, right? So after this function completes, all I do is answer less than 0. It means that I cannot go from the 0th index to the last index, right? If answer is less than 0, that we have already seen here, right? Answer is less than 0 means it's close to this min value, right? 1 plus some min value and so on. So just return minus 1, or else return the maximum number of steps that you have calculated. Simple, right? Yes, I can understand the recursive approach is more intuitive. I created the video for iterative approach, the first one that I created, because this was an easy problem, right? So understanding the iterative approach is also very easy. So if you like the recursive approach, you can go with this solution. But to learn, I would suggest go and watch that solution as well, right? That will be, you'll learn something new. That's the main thing I want to tell, right? Because in today's contest, I saw that there were a couple of deep dynamic programming problems, right? So if you're new to DP, probably referring these problems will be very beneficial, right? So yes, that's it for this solution. I hope you learned something new from this video. Do support it by giving a thumbs up. Do subscribe to the channel as well. In case you have any queries, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.